So once you've completed up to question 4 on the skill, it's going to ask you to refer to activity 4 that we went through in a previous video. In that video that we calculated at 60 hertz that the L1 solenoid was 3.2 henries and that the L2 solenoid was 0.91 henries. Referring back to our first formula, we see that if we want to calculate the total henries, we need to add them up. And then we're going to run them through another formula. So calculating our total henries in this previous circuit here, we see that we have a Henry total of 4.11. Our formula for XL, it is 2 pi times the frequency of 60 hertz times our Henry total of 4.11. So when we do that, we should get an XL of, I believe, 1549.437. We'll just say 1549. So using Ohm's law, and I know that I have 24 volts AC, I can take 24 volts AC and I divide it by my XL in ohms, 1549. We just rounded that off. So when I do that, I have 24 divided by 1549. Okay, and that roughly comes up to 15 milliamps. Now, I don't have this exact circuit built in the real world. I do know what your simulator says, and we can look at that. Here we have the formula here, and if we do that, it's 0.015 amps. So I have the simulator up, and let's look at that real quickly. And we'll see here that it says 20 milliamps. Well, that's pretty close. You know, I know it's not exact, but it is a simulator. I would have thought it would have did a better job right there, but it didn't. So that is how you calculate the XL here, because you're going to have to plug in 50 hertz, 60 hertz. Well, you have these from the other calculation, and you'll have to plug these in. Then we connect the circuit. You can do that virtually if you'd like. Then you're going to walk through here, and it tells you that the theoretical current at 50 hertz. What is that? What is the theoretical current at 60 hertz? Here it's going to say operate the circuit. You can hook that up in the activity 4 if you'd like to. And are the two values close? Well, they're pretty close. Then we move down to activity 10, where we begin to calculate parallel inductance. You should recognize this formula. It's the inverse formula for calculating resistors in parallel. So all they did was put in L instead of R. So you can do that calculation. And let's see where it asks you to do the next circuit. So you can perform the same calculations here there is a different formula. Well, no, it's the same formula, but because we calculated the henries in parallel, you're going to plug it into the same formula over here, the XL. And that is going to show your total inductive reactance. So over here, you would plug in these values here. Let's see, we had, depending on what it is, the solenoid was 3.2 henries, and the transformer was 0.91 henries at 60 hertz. Refer to your course layout. I've put those numbers in there. You should have already calculated those. That'll help you fill out the rest of this. If you have any questions, send me an email.